Hi.
I'm happy to be back again. I met you all last year and talked about composable infrastructure, very nascent technology. But what I want to do is provide you updates today on some of the significant milestones and investments we're making. You know, it's always a challenge to follow Luca because he always uses some interesting analogies. And so I was thinking about, well, his whole hotel analogy. And I guess the space that we're talking about here, some of the challenges we're trying to solve with the next generation of data infrastructure is really trying to provide the flexibility and agility of different types of capabilities and service. So maybe instead of the fixed hotel that Luca was referring to, it's the flexibility I like of being able to go to VRBO and go to different types of, and get different types of services, or using Uber and using different types of Uber for a different level of service. Anyway, maybe the analogy doesn't work, but it's always fun to follow Luca. In any case, let's first step back and talk about the challenges that we're trying to overcome when we talk about zettabyte infrastructure or zettabyte data and the next generation data infrastructure. You could really put them into three different categories. One is, and was talked about earlier from a device level, it's about utilization and TCO is the first category. The second is agility, and that has to do with the dynamics of the workflow at scale. And then the third is, we've talked about traditional data centers, we've talked about edge, and so there's this whole notion of how do we get the benefits of data locality, but the data close to the different resources. So in the first case, the traditional shared nothing model, that leverages the traditional server with CPU, memory, and storage. The challenge in that model has become that in order to provide the greatest utilization, you need a variety of different traditional servers to meet the demands. The fewer the traditional servers to meet the demands, then the worse your utilization can be. A variety of people said that it might be up to only a 40% utilization. It's going to depend on how you deploy what you have. There's also been some discussion earlier today about, maybe not the growth and performance in terms of compute. So now the traditional server that used to comprise CPU, memory, and storage, now we're seeing other compute resources being introduced. Accelerators, whether it be FPGA or GPUs. Well, now you've got more flavors and more combinations, and that creates a different problem. Last but not least is we're also seeing these new use cases, modern workflows like machine learning, where you need the data to be close to whatever that compute resource is. So do you want to move the data to the compute, or do you want to move the compute to the data? There's a trade-off and a challenge there. So these are some of the problems that the whole CDI, composable disaggregated infrastructure, is trying to solve. In that, we're trying to break those resources, disaggregate them, so they can be the leanest possible combination of resources, but then allow them to be virtually composed. Then we can create a composite, which is a logical server, if you will, that then can be modified depending on the dynamics of the workload. What's the biggest enabler for this? It's the fabric. It's NVMe over fabric. So this started back in 2014. That's when work in this space first began. Mid-2016 is when the standard became real. We've been a participant in this because we believe that NVMe over fabric is going to be the foundation for the next generation infrastructure. We also believe that the universal backplane will be Ethernet ultimately. There's maturation to be done, but the ultimate desire is to take these different resources, put them in pools so that they can be shared. So now these are not trapped entities. So that helps your resource utilization. And the whole objective with NVMe over fabric is to provide the sharing possibility with the minimal performance impact. And we're going to show you some proof points where this is becoming a reality. Because in the end solution, now we can create different composites to address different workloads in a very dynamic way. So we're providing cloud-like capabilities, agility, and at scale with NVMe over Fabric. But I thought about something very contentious. I thought, well, you know, we could do a poll and figure out where everybody thought either the market or Western Digital was on this technology life cycle. But that tends to be somewhat subjective. It's based on expectation. So I think that would be a healthy debate we might save for later in the evening. The importance in any technology life cycle, though, is the development of the technology so it can be adopted and accelerate this vision. So we've established investments and leadership in 4 key areas since we talked last year. We have shipping product that's being used by customers. We have also introduced this open API. Everything that we're doing is open. This open API allows you to configure and compose and decompose and recompose. The other thing that we've done is last year we invested in Kazan Networks. Kazan Networks is very strategic to us because NVMe over Fabrics is strategic as we look at the next generation data infrastructure. Kazan Networks has been involved in NVMe over Fabrics since their founding in 2014. Very high performant. We'll talk about some of the other benefits of the products that they're bringing to WD and we are integrating going forward. Last but not least, to make this realizable in a non-proprietary way, we're committed to open. Heterogeneity introduces complexity, as we all know. So what we've also announced and launched late last year is this notion of an Open Composable Interoperability Lab. Because at the end of the day, end-to-end, we want the different parts of this ecosystem to interoperate and be compliant, interoperate end-to-end and be compliant with the Open Composable API that we offer up through Open Compute. So as a few proof points, this product, this latest incarnation of this product, we announced at FMS. This leverages our latest and greatest 3D NAND inside. This is a 3U form factor with 10 fabric devices, which are attached to the fabric, can be shared across a plethora of compute devices. And this provides the highest performance density that's available in the market, whether you want to measure that based on IOPS or throughput. And you can see the numbers here. We've just been notified that we're one of the finalists for Storage Magazine Product of the Year in 2019. The API is instrumental, if you will. If you think about the whole composable ecosystem, you have the devices that are disaggregated. You have the fabric, which is the connective tissue amongst all the resources that you put in pools, and then you can configure and reconfigure. The API is basically that instrument that allows you to tie to either the orchestration level or the business application or some combination of both. So effectively, it is the interface that allows anybody in this open community to integrate our devices, whether it be a fast device or a high capacity device that we might present over a fabric, and be able to compose that for different workloads and different solutions. And of course, it's all attached to a fabric so that it's easily accessible and shareable, but then it can be easily modified and reconfigured. So we're no longer trapped within the confines of a traditional server with whatever the components are inside. So you've got
disk
your
up there, Scott.
Pardon me?
You have disk up there?
I do have disk up there. And if you recall, Ray, back in FMS 2018, we did a proof of concept demonstration where we actually presented disk over an NVMe-oF fabric, and you could manage it via namespaces. And you and others, I think, were like, well, that's an interesting concept. And the reason we did that, if you think about the scale of the next generation infrastructure, that sort of construct to make the overall management simpler is pretty paramount, as opposed to having a variety of different management constructs based on different types of storage or different types of resources. So effectively, disk was presented as NVMe namespaces, right, when we did that proof of concept. It just so happens to have a different SLA and different characteristics, right, in terms of price, performance, capacity, et cetera. But the beauty is you just manage it in a very similar fashion over the fabric. So what that shows is the architecture that we had announced a year and a half ago. It also validates what the extensibility of the architecture is, as well as our API. So our API is pretty diverse, and it is available on Open Compute, but it provides the ability and shows extensibility for all sorts of resources, whether it be a disk, whether it be SSD, whether it be an accelerator, compute, or the like. So let me talk a little bit about Kazan Networks. Again, this was a strategic investment for us. Very, very high performant bridge, if you will, from a PCI to Ethernet. And this is strategic for us because we believe that NVMe over Fabric is part of the future of the next generation data center. And so we wanted to have the ability to integrate and have higher influence in and accelerate that technology, both not only as a standalone component in the industry, but also within our platforms and our products. So that twofold sort of push, we believe will make the NVMe over Fabric and CDI space a reality sooner than otherwise. So why did we pick Kazan? Boils down to basically three things. The most high performant out there, lowest power, actually four things, lowest cost, and lowest density. Everything is done via hardware. So we don't have a DRAM footprint. We don't have the cost associated with DRAM or latency associated with DRAM. It's a very high performant ASIC from end to end in the I/O path. It's all hardware based. There's no firmware interference. So from this bridge to go from one end to the other in a single pass, it's inducing less than a half a microsecond of latency. That's the starting point. That's on the target. In the future, we envision with the roadmap that we'll have control over both endpoints. Not only the target, but also the initiator. And when you do that, you can do a lot of interesting things in between. Now, it doesn't mean that we're still not open or committed to open, because we also support other things within the infrastructure. We're not looking to necessarily own all the initiators as well, but it does provide us some flexibility. So with that, we get DAS-like performance, but we get it over a fabric such that it can be shared. Again, that helps your TCO. It helps with the dynamics in large-scale infrastructures where you need a lot more agility as opposed to fixed workloads and everything is dedicated for a specific workload.
So how would we, in that case, just as a, hypothetically, how would we connect, say, multiple GPUs that are in a device like Tesla GPUs or something like that? How would we connect those across that network?
It's an interesting question. We actually, in a little bit later, I'll show us a slide with some of the ecosystem, but there are a variety of different layers, right? The resources, but there's the orchestration layer as well. And in fact, at Supercompute, we did a demonstration and talked about collaboration that we're doing with Liqid. Liqid is very focused on GPU and GPU sorts of use cases, if you will. So our demonstration, we actually showed the leverage of our API, their orchestration layer, and between our two different booths, we actually connected our flash-based storage, our F3100, with their GPU in another booth across the fabric.
And when you say fabric at that point, I mean, they're using a PCIe fabric.
They're using
not using NVMe. So
they're using a PCIe fabric, but they also they effectively have this PCIe to Ethernet sort of gateway. And so that's where we can plug in, for lack of better words, we can plug in our F3100, which is Ethernet based, but their orchestration layer can support both through our API.
So the GPU, the PCI thing with the GPU is a great thing, but actually there are companies like VMware, for example, they are pushing for sharing GPUs
right
across the network in a virtual way, okay? So this will have an impact, I mean, for practically everybody, while with the hardware play, you need the specific infrastructure. So is the composability going to happen again in traditional enterprises? Because it's much easier to virtualize than to build a new infrastructure based on a PCI shared network or an, not FCOE, but actually PCI like Liqid or others like that. I mean,
yeah, there's a couple of different dimensions to your statement and/or question. So one is kind of related to the fabric, and that's what Chris was kind of pushing on as well. Actually, the architecture in our API, fundamentally, we're agnostic to the fabric, right? NVMe over fabric to us could be, we picked Ethernet because we think it will be the most ubiquitous, but it could be fiber channel, it could be whatever. We're ambivalent, but what we picked was where we thought the data center of the future is going to be and what's going to be the most ubiquitous. But there's extensibility regardless. So the proof point with Liqid is they particularly have some things that are PCIe based. We have Ethernet based, and we're able to, with a bridge of sorts, we're able to connect the two and leverage the beauty of both worlds. So then the other thing that you touched on was with regard to VMware and perhaps in the enterprise. So fundamentally, I look at CDI, composable disaggregated infrastructure, it is for large scale. Whether it be hyperscale or it be large enterprises, it will be relevant. It also applies, the beauty of it that some people lose sight of, applies to environments that could be virtualized, bare metal, or containerized. So there really isn't a limitation as this technology continues to mature. So, if you want to leverage CDI in a virtual environment, there's nothing that would prohibit that. But if you also want to use it in a bare metal or a containerized environment, it's applicable to all three, which also, suggests that it's got great extensibility in the future as well.
So we agree. I mean, my point was this. Composability is something that I can see in very large infrastructure, bare metal kind of things, while for traditional enterprises, virtualization is good enough. It's still good enough. I mean, less of a problem. They don't have to design or redesign anything.
No, they don't. What this does is I think it provides greater extensibility through those three different paths, and it can do things. We also can do things at smaller scale versus larger scale. So I think it just gives a variety of options for the future, whether it be the enterprise or the hyperscalers. Let me talk about the proof in the performance is, that's always been a question. people say, well, I like the DAS-like performance, but the restrictions in shareability obviously is something that we're trying to break. What this shows is a couple of generations of high performance. This is an existing device. This was its predecessor that dates back about 5 years ago. The reason I show that is because of some of the things that date back to Kazan and NVMe over fabrics and some of the things that they've been doing over the years in conjunction with Western Digital prior to us acquiring them. But basically what this shows is whether it's DAS or over the fabric, you can see that the IOPS are essentially the same versus what you would see in a DAS environment. The latency, you can see that there is a small difference here, but this difference is on the order of 7 microseconds. So that difference is well under 10%. So minimal impact on latency, but now you've got the shareability of all of the storage to be used by what other compute resources are available, whether it be traditional CPU or accelerators.
That performance would just be a standard NVMe over fabric accessing the SSD. That's not necessarily your composable infrastructure in front of it or anything like that, right?
This performance is from a host. Basically, it's a host saying, I want to do something. I either want to write or I want to read to that device, and then I need the acknowledgement back. So it's a complete round trip from a host perspective. So it's basically taken what you would do within a DAS environment,
right,
but now we're putting an extension cord on it, right? But yet we're demonstrating that that extension cord opens it up to be used by others without a lot of latency on that extension cord.
From my perspective, it's accessing the SSD over NVMe over fabric. The latency is 7 microseconds different. I understand that. When you start plugging in composable infrastructure on top of that, you don't think the latency changes at all for the NVMe over fabric? I mean,
actually, I think you're pushing on something that's rather interesting. And I think what I would tell you, Ray, is this, depending on the application, this 7 microseconds may not even be observable. In other words, there may be things higher up in the application layer that you won't even, that difference is imperceptible, as opposed to a detriment.
I guess I don't understand what I'm saying, but what I'm trying to say is that standard NVMe over fabric, it has a 7 microsecond latency on top of direct access to the NVMe drive. I understand that. But I envision the composable infrastructure as being yet another whole orchestration layer, a whole other environment that's trying to set up this fabric almost on demand, right?
Sure, sure.
But once it's set up, I guess it's NVMe over fabric. It doesn't change the dynamics here. It's the same whether it was a fixed NVMe over fabric or a composable infrastructure.
Right.
That's what you're saying.
And what the benefit, though, is what we're trying to show is there's a minimal performance impact, but it gives you flexibility, right? Because the alternative goes back to the problem statement that we talked about in the beginning, right? If you're stranding resources, or not utilizing them, or you have to move the data from one repository, for lack of better words, to another repository, that's a much bigger challenge. This gives you the dynamics or the agility that if you do have flexible workloads. On the other hand, let's say you say, I really don't have that flexible of a workload. So what's in this for me? Well, the disaggregated resources, when you disaggregate them, you still make them as lean as possible, for lack of better words, right? So they become building blocks that even if you don't have the dynamics and you're going to recompose, now you have resources that are as lean as possible, as opposed to the HCI model where you've got a plethora of SKUs to provide you the appropriate granularity.
It's like right sizing just for the
That's right.
Yeah.
That's right. So you've got building blocks that right size, and then you've got the flexibility to move those building blocks around in a dynamic way if indeed your infrastructure or data workloads require that.
Yeah, so when you finish the workload, you can just
That's
move
right.
it away, right?
That's right. So this is my last slide, but this kind of shows a little bit, from an ecosystem, what I was referencing before. So we've partnered with a lot of orchestration players. At FMS 2018, we showed different business apps using our devices. Obviously, we've got the different resources. The API supports all of these resources, and that's open in the community. And then from a fabric perspective, we're partnered with the main players, as you see here. And back to the Open Composable Compatibility Lab, that's an announcement that we made, that we've invested with Mellanox and Broadcom, because this is an open community. So we want to ensure that end-to-end things are interoperable. We all would like to think that if you follow a standard, things will be interoperable, but there are wrinkles. And then what it also does is allows us to validate the compliance with the open API, that it's open for everybody to use. So some pretty significant investments, some pretty significant proof points that show that, yes, we are advancing the technology and the leadership. So regardless of your perception of that life cycle, these are key things that we've made since we talked last year.
Well, Scott, you've got memory on this list.
Yep.
Memory today is not an NVMe over Fabric access device.
You are correct. You are correct. And I think we had this conversation, either with you or Chris, I forget.
I think we had it.
I think we had the conversation a year ago.
But that's before we talked about things like CCIX and
that's right.
the other
C6.
different solutions that are coming along to put some of that memory on the
That's right.
PCI bus.
This kind of gets back to, do you think that, is the story beneficial and realizable until you have it all? Kind of the Big Bang Theory? Or can we provide benefit to our customers, but show the architecture and the API and show also that it's extensible, such that when memory is disaggregated, then that becomes yet another resource in a pool that you can compose. We believe that it is a journey, but we also believe that the maturation that we've talked about in everything but the memory so far is becoming a reality. So memory, I think over time will become disaggregated, but I agree with you, it isn't today.
But also CPU. It's not
Well,
disaggregated. So, I mean,
since it's not disaggregated, yeah, I think the same way. Since it's not disaggregated, you still have the tie between CPU and memory, right? But I think we're proving the benefits, and we're proving with some of the proof points that the other devices, we are making a good progress in terms of the disaggregation and then the benefit that they can provide.
You really need to Intel to be involved to help you change the chipset to
Or
allow
AMD
you
for
to
that
have the memory done in a different way, so it's not.
Or we also have our AMD friends here.
Or AMD to do it, yeah.
That's
by
right.
the way.
That's right.
But that seems to be that sort of a missing gap. Your partnership list doesn't show at the moment.
That's right. I think we'll get there. We're making good progress. I mean, if we think about where we were a year ago, and while we did show some product and some proof of concept, we had talked about the architecture of the API, but now we're seeing the reality of it, right? We're seeing the API leveraged with different orchestration layers and the benefits, and providing the connectivity across the fabric so that we can deliver that flexibility.